Is it recording? Yes. Right?
Yes, it's recording.
Awesome. Okay, well, hello everyone who's watching this. The purpose of this workshop, this is Fundamentals of Solidworks, Part 2. This is to show you how to assemble multiple parts in SolidWorks and make drawings of them as well. So we're going to start with the assembly. So one of the things you should, if you're going to follow along, you should have these 4 parts from Part 1. One of the things you can do in SolidWorks is you can go to one of your parts and you can have it be the main part of your assembly. So to start any assembly, you need that main part that's kind of going to be the origin for all the other parts to mate to, which is just like where they attach. And so we're going to make the body our primary component. So what we can do is we can go up here to the top left, right where it says new. We can click the drop down arrow or click on new. It'll pop up like a separate window. We can go down to make assembly from part/assembly. When we click that, you should be on a new screen and all the documents you have open will automatically appear here. And so you can just drag. I have mine named demonstration card 2, and that's my body. Oh shit, that's not drag. Okay, never mind, not drag, just select and click, and bam. So now we're in an assembly. This isn't a drawing anymore. The name kind of changed at the top. I can't see it, the zoom thing's in the way. But it says like assembly, right? Unnamed assembly or something. So as you can see here, then things different. So we have our part here, and we can even click the drop down arrow and still see like all the extrudes and cuts and everything. Most importantly, it's planes. And then we also have this thing here called mates, and that's just like how things are connected together. But to add more components, you just come up here under the assembly tab in the top left, insert components. Yeah. And then just click. We want 2 axles, right? There's kind of 2 ways you can go about this. You can like insert all your parts at once, or you can do it one at a time. I like to just get everything out and then slap it all together. So we need 4 pins. You can also select a part, Control C to like copy it, and then like V, 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 paste it multiple times. As you can see, each one you input gets a different like number designation. You can rename these if you want. Insert components. We need the wheels, right? Right. All right, and we need 4 of those. Bam. And so that's all the parts for this assembly. All right. So now we can start putting them together and show how they fit together in a 3D space. So we're going to go over here to this little button under the assembly tab, mate. It's got a little paper clip. You click that, and so now you're in the mating thing, whatever, menu. And so you have different types of mates. SolidWorks is pretty smart. When you start clicking on stuff, it'll kind of know how you want to mate it already. Oh no, what's happening? Oh. You guys following along? My thing, my SolidWorks is kind of spazzing out. All right, we're back. So you just start selecting stuff, and SolidWorks is smart enough to kind of know how things fit together. So I don't have any specific type of mate selected, but I'm going to click on the outer surface, the like cylinder shaped surface of one of the axles. See, it already says like face 1 axle. And then I'm going to click on the inner surface of the car, so where I want the axle to go. And it's already gonna concentrically mate it, even though I didn't tell it to concentrically mate. That's what I wanted it to do. SolidWorks is usually pretty smart with these standard mates. So you can see they're called standard mates here on the left. And it knows pretty much what you want to do. Okay, before like you start just clicking on everything really fast to put things together, you got to make sure you click that check mark, or else you'll just keep changing the mate selections right here, this box, and you'll start mating things you don't want to mate together. So always make sure that after you do your little mate, click that check mark, and then you do the next one. See, but I'm going to exit the mate menu real quick just to demonstrate something. So now this axle is concentric to that hole on the body, right? But guess what? That's all they are. They're just concentric. So see, this thing can be all the way over here, and SolidWorks won't know the difference because it doesn't know it's supposed to be anywhere else. But we want this to be like inside the car at all times. You know, that's where the axle's supposed to go. So you can add multiple mates to these things. Um, and there's two ways we can go about this. We could either do what's called a width mate and mate it say like, hey, this end of the axle and this end of the axle are supposed to be like in between this side and this side of the car, and I'll put it like perfectly in the middle. Or we can mate the planes of the individual parts together. And what I mean by that, we'll do that one first. The planes mate is we can click on this drop down arrow for the body, right? Um, we can see if we go to its planes, the front plane, top plane, right plane, we can see that it still has its cardinal planes. Sorry, let me just adjust it. Uh, bam, bam, bam. It still has its cardinal planes, and most importantly, the front plane is still like bisecting it because it's its own front plane. And likewise, if we go to the axle of the one we already have made it uh, not centripically, concentrically to our car, you can see it has its ones too. In this case, it's my axle 2, but you might have selected axle 1. Um, so we can select the 2 front planes. In this case, as you can see, they're almost already lined up, but they're not mated together. We can click that mate, and bam, it already shifted it over. It already knows what you want before you even want it. It's amazing. But yes, so it already has them selected because we already selected them. We already made them together. If we didn't have it selected, say um, like I didn't have this one, I only had one of them selected, you can click up here in the top left of the viewing screen, uh, just right of this whole like column on the left, you can click this little drop down arrow. Might be a little hard to see on my screen because I have everything like dark theme, but right underneath the assembly, and you can click the drop down arrow and see all your parts. And they have their own little drop down arrows, see? And then you can select from, in my case, axle 2, you can select that front plane and it will mate together. You can specify, in this case, they already knew we wanted a coincidence, but if you want like parallel, you can specify a distance they are apart or a degrees they are apart, weird stuff. But we'll just click that check mark, and now, see, it doesn't move, it only rotates in place. It won't slide out of the body, so it's just kind of rotating in place. And that's awesome. So now that we did that, let's do the same thing with axle 2, or the other axle, in my case it's axle 1. Uh, and I'll show you the width mates, which is an advanced mate. So we'll get it concentric, again, just outer face of the axle, and then inside of the body, little hole it has, and it will already kind of put you in concentric. We're going to check mark that. And then now to do advanced mates, you have to kind of, SolidWorks is smart, but it's not that smart. So you kind of have to tell it what advanced mate you want to do before you start selecting everything. So you're going to click right here on the left underneath standard mates. It's going to be advanced mates. Click the drop down arrow. And then it's going to like automatically retract the standard mates. So don't keep looking down, kind of look back up. And right here you have things like profile center, symmetric, width, path mate, more advanced ways of saying, hey, these two parts are supposed to move like this together. The one we're interested in is the width mate. And so what this one does is you can select 2 sides or like lines of two different parts or multiple parts, and that'll be like with one, and then the other one's like with two. You do the same thing for another set of parts or another part, and it'll be like, okay, you want these to be like midpoint with each other, like right lined up. You get me? So in our case, we're going to select this end, one of the circular ends of our axle, the other circular end of our axle, and then we're going to select one side of our car and the other side of our car, and see it's already going to slide it in, and they're perfectly in the middle. If I get normal to that face, see, boom, boom, you can't even see the other axle because it's perfectly flush, see? So, like, that's a good way to fit things perfectly together if in the case that you don't have the planes lining up with each other. Like if we design this axle and we just projected it straight out of the front plane instead of doing it a mid plane projection, extrusion, so then the front plane was all the way at one of these sides, one side right here, then we couldn't just mate the planes there, but we could still do this because this isn't dependent on like the cardinal planes of the part. So we're going to click OK, and bam, we already got our axles in. It's pretty nice. So we'll do the same thing with the wheels, and with the wheels won't have as rigid constraints. They're just kind of going to be on the axles. So we check marked so that we're out of that advanced mate. We'll just click on the inside of that and slap it on our axle. Oh, sorry, we're still in advanced mates. See, so we gotta go back to standard mates. If something's not like happening, maybe SolidWorks is like, I'm not really sure how you're putting things together. Oh, like just go and say what you want it to do. And so you can, bam, see it wasn't really knowing what I wanted to do, so I told it, okay, make it concentric, and bam, it already slapped it there. Then you can lock rotation and stuff, things like that to make sure things don't move around. We'll say okay to that, and we'll do that 3 more times for the other wheels. See what I mean? Don't always make sure you check mark it before you start selecting other stuff. You can inevitably mess things up. Bam. Check mark. Oh, bam. All right, perfect. So yeah, these wheels, they're kind of still floating. Same thing with the axles before we gave them that other mate. They're just kind of floating around. We'll change that in a second. For now, I'm going to put them a little closer so we have a good view of the pin slots. But we're going to make these pins now. And these pins, to get them to go into that hole, you're going to have to do a few things. You get me? So we can select one face, any face will do, and we can mate it to the inside of the pinhole. And well, bam, see if we check mark that. And let me just show you. So it's mated to that face. It's going to stay on that face, but it's kind of just free to go everywhere else. So we got to specify another face or a line. You can also mate edges with each other with faces or things. You can mate anything together, really. So like in this case, we could mate this line with the anterior face. And we'll say coincident. Yes. And see, that didn't really do anything because that's kind of re-specifying that, okay, I'm just constricted to this little plane of movement. So we kind of need to select this face to mate here to get it to be inside the pinhole. So we'll like, bam, see, and now it's inside the pinhole, but it can still like, ooh, go in and out of the hole and even rotate the shaft. It's pretty cool. All right. So, is there a way to change this? Why, yes. There's always a way to do things weird. If we go back to our advanced mates, we can do with mate again. we can select the two sides of the pin, and then well, this thing's rounded. How are we going to do the width mate? If we just select the whole surface, bam, it already kind of knows like, hey, this thing's circular, but circle things have a midpoint. And so it'll put it right in the middle of the circle. We'll check mark that, and it's perfect. It's very nice. Very nice indeed. Just to make everything look nice, we can select this flat face of the wheel if you design the wheel correctly from the first one. As you can see when you select a part, because it knows you can't mate a part to itself unless you have two of the same part, like it's going to gray it out and you can select things through it. This is awesome if you have like things inside of other things when in your assembly. So it will kind of gray it out and you can select things through that part already. So bam, we'll make them, oh, we're still in advanced mates, so we gotta go back to standard mates here on the left, hit that coincident, what bam, and there we are. So just like we did the width mate with this pin, to get it to be right in the middle, we could have also done a planar mate, and I'll do that for this next one. So like I said, we'll uh, get these planes together, we'll slap them all together, well, bam, kind of teleport it over there. Um, hmm, yes. So you just need like two 90-degree faces to really get things to sit inside of each other. Bam. And then we can, let's see, what pin is this? What is this? Uh, exit mates real fast. What pin is this? Oh, it's pin 2. See right here, it highlighted it when I clicked on it. So it's pin card 2. Let me minimize some of these to make it look nicer. Um, so we can select pin 2. We can select its, like I said, this pin was a mid-plane extrusion. So its front plane is right in the middle of the part. And we can go to, this is axle 2 in my case. Click down on it. And in this case, the top plane, and just control click. So I have both of them selected. Here's pin 2's little front plane, and then this is the top plane of the other part. As you can see, they're almost parallel already, but we can mate them together just so it's doing the same thing as the width mate, basically. Um, Sometimes doing this is a little faster than clicking all the sides of the width mate, but that's for you to decide. At the end of the day, they do the same thing. And see, when you have the plane selected, since it's just a simple coincident mate, SolidWorks can already infer what you want to do and just automatically do it. Bam. And so now that's pretty much how you do it. Uh, in this little case, those are like the two ways you can mate it, pretty much. So I'll just make these other pins real fast, and we'll get on with it. All right. So same thing. Just bam. Sometimes you gotta like move your assembly around. I like to be freestyling when I assemble. You know, the kind of rotating everything around like this. But some people just like alternate between the cardinal views. Bam. Um, do width mate for this one. It's pretty fun doing width mates. There's a lot more in-depth mates, but for the purpose of this simple demonstration, I'll just be showing you these standard mates. We gotta go back to standard mate, hit that coincidence. Bam. Oh, what happened there? Huh. What's going on there? I probably misclicked something. So in the event that you accidentally mate something, it is going to happen. Let me now show you what to do. You click, remember I pointed out that there was this mate thing on the left when we looked at all our parts? You're going to click that drop arrow and it lists all the mates you've made. And when you're going through it, like you're kind of hovering over it, it shows what's mated to what. and it's in order of what you've done most recently. Like the most recent things at the bottom, the first thing you did is at the top. So, see right here, I accidentally mated the front head of this axle with the inside of this wheel. So I can just select that, and you could actually like edit it, I suppose, and change from the axle. You could delete that and then select this pin face. Ah! All right, that's not what we want to do. Yeah, SolidWorks does weird things sometimes, especially when you're trying to like make it not do those things. So at the end of the day, it's usually just better to delete this stuff. When you're mating really complex parts and you're doing a lot of mates to get these parts to fit together the way you want, um, you might have to like manually line them up in order for SolidWorks to like realize, oh, that's what you wanted. Uh, but this is very simple assembly. We shouldn't have to do that. See? So I deleted that incorrect mate and then I specified, make sure that I was doing it right. Bam, check mark. Sometimes these mates get a little monotonous. Uh, I think you can undo it with control. Someone just asked. Yes, you can. Yeah, you can just put control Z and undo it. Yeah, but you know, if that doesn't work, go back and delete. Plus that mates menu shows you all the mates that there are and what kind they are. So in case you need to go back and reference it, always hit that check mark, kids. Be sure to like and subscribe. All right. Bam. Oh, bam. All right, thanks for that question, JC. Very good question. Um, Screw it, we'll do a plain mate of this. What pin is this? The exit mates, select it, it's pin 4. It's sometimes easier to do these plain mates outside of the mate menu, just because you can see all your things in this little thing instead of the one inside of the window. This is axle 1, so it's going to be the top plane, mate, bam. All right, and that's it. Oh, wait, that isn't it. I almost forgot. The funnest mate of them all. All right, bam. All right, now that is it. We can go like that. We can exit the mates. There is, excuse me, there's our car. Looks pretty nice. So there's a lot more to assemblies, but for this fundamental demonstration of SolidWorks, that's, you know, all there is to it. So now we can start drawing our parts, which some of you may have experience with. It's a pretty fundamental skill. If you're taking engineering graphics, that's the main skill you'll learn, is how to draw the parts both manually and in SolidWorks. But if you're not taking that, maybe you're not a engineering major or you just haven't signed up for that class yet, we're gonna start this. All right. Yeah, let's save this assembly. So I already have, I did a first car as practice. Um, SolidWorks assemblies, see it says type SolidWorks assembly document. They save as different from, they're a different file from parts. So you can name them the same thing as a part. For instance, my body is also named demonstration car 2. But since it's an assembly, I have in my files demonstration car 2 like twice. And it's just one of them's the SolidWorks assembly, and it'll say like .assembly. See, it says .sldasm. It's important to just kind of distinguish that. Maybe you want to say like demonstration car 2 assembly. I think I forgot how to spell this assembly, man. All right. Well, bam. So there's our assembly. Now we want to make drawings not only of our parts, but also our assembly, just to show people what's what. Um, Before that, did I want to do anything? Uh, I guess if I want to do anything, it would be that you can still edit parts while they're in assemblies. That feature is not limited to NX. So you can literally just like right click on a part and then edit part. Oh yeah, yeah, sure. Sometimes, uh, what the hell? But I already saved you. What? Yeah, that was kind of weird. Um, well, I lost my train of thought. Sometimes, uh, you just need to make a quick little edit. But you can edit things while they're assemblies. This is good if you're trying to design a part to connect two elements and you already have them in an assembly, so you know how they're going to be. You just don't want to measure them, kind of, or you just want to use the theoretical measurements. So you can go design parts in an assembly, even. You can create new parts and you can edit components as well, as you can see. Um, so what did I want to do? I show you a feature I guess I didn't show you in the first workshop. I forgot to mention the chamfer feature. If we're in features on a part, you can go all the way to the right, right before linear pattern. You have fillet, and if you click the down arrow, chamfer. A fillet is a radius on the edge of a part. It rounds the part. A chamfer is a flat angle that cuts a 90-degree. In this case, we'll slap a fillet. And if you select uh, a whole face, it'll try and fillet the whole face. In addition to doing that, you can select individual lines. And you select one line, it kind of like tries to reason, all right, where can I logically terminate this fillet? So it may go beyond what you already selected. Um, so yeah, yeah, fun times. We'll just fillet all these edges. Um, Kind of don't want this circle to be filleted. It's kind of, I think I see the errors of my ways. Yeah, I selected the whole face, so it included these circles, these holes. And I kind of don't want that, so sometimes it's better to select each individual line. You can just keep clicking lines and just do them on this face and this bottom line too. So in addition to saying you want to fillet these, you can specify on the left side the type of fillet, an asymmetric or symmetric fillet, the size of the fillet. We'll leave it at a tenth of an inch, but you can increase it. If you're not seeing this preview on a chamfer fillet, it's usually because your fillet radius or your chamfer angle slash side length is too large. So it's like it can't render it because you're cutting the whole part off. So if you're not seeing it being rendered, it's usually because your chamfer fillet is too large. So just try reducing the size until you see it. That also gives you kind of a scale of what your part is. It's very easy to get lost in scale with SolidWorks because you just kind of like zoom in and there's no like, okay, put it back to actual size. You're kind of just free floating with size. Here, gotta look at numbers, implicit things. So we just exit, check mark the sketch, exit edit component, and bam, we edited our demonstration car 1 within, or demonstration car 2, the body within our assembly. We didn't open the separate part and edit it. If you open one of these parts, or in this case it's only 4 parts multiple times, if you open like the wheel and I change something, you would get the thing that you would get a pop-up saying rebuild the assembly because it knows that you changed one of these parts and you just check mark it and it would rebuild the assembly with the new parts basically. Change out all these old parts and put the new ones in. if you drastically change a part, it'll interfere with these mates. So always be conscious of that when you're modifying parts. Like if I were to delete this inside circle on the wheel and I rebuilt this, and I updated this or rebuilt this assembly, it would give me an error because it no longer has that hole to mate concentrically to the axle. All right, that's all I want to show you for the assemblies. So now let's get on with the drawings. So same way we made the assemblies, we can click new, and right here it is on the drop down arrow. If we click new, so we can hit drawing, but this will make a new one. We want to start our drawings with this thing already selected. So we'll put make drawing from assembly / part. And we'll get this. We're now in Solidworks drawings. We have multiple paper sizes. If you're not seeing all these paper sizes, it's probably because you have this check marked. The only show standard formats. A4 landscape is usually the standard. ANSI. It's not a standard piece of paper, mind you. See, it's 11.69 by 8.26. A standard piece of paper, a letter sheet in the US, is 11 by 8.5. That's somewhere in here. If not, you can specify it. But we're going to use this for most intents and purposes. Landscape A4 works perfectly fine. So this is SolidWorks drawing. As you can see, we already have our little paper. It's got some designations like coordinates, and it's got a whole little box at the bottom for information. All right. Thank you for coming, JC. Appreciate you being here. All right. So what we're going to do is we have right here, if you look on the right side, we have this tiny little tab sticking out. This is like some extra information. This is available in all of like the SolidWorks parts, but the one we're concerned about is the one that's already selected on my screen. This one with the little square with some Tetris pieces on it. It's called View Palette. And this is the one where we're going to get our drawings already rendered from our parts and just slap them on the paper. So always start good engineering practice, front view, and SolidWorks already knows good engineering practice. It'll give you the right view and the top view, 90-degree mated, and you can even slap that isometric in there. And bam, there's our 3 drawings. Look kind of bad, but we'll change that in a bit. So in general format, it's good to have your drawing first, your whole assembly in the beginning of your drawings, so people get an idea of where the parts that follow fit into the assembly. So we will start changing these things, make them larger. It's pretty small on the paper. If we want to make them larger, we select the drawing. It'll put us in the kind of like edit drawing view screen on the left side. And we will just scroll down. One of these tabs is called Scale. We'll click Custom Scale. We can set it to whatever we want. See, 1/2. All of these are kind of mated together, so their scale changes all at once. That's a little big for some of these. So maybe 1/2 isn't the best size. It's kind of hidden, but if you scroll up on the scale, you'll see that there's a user-defined option. In the user-defined, let's use this little box right here. You can specify whatever scale you want. This, the first number goes to the size of the drawing. That goes to the size of the part. The second number goes to the size of the drawing. So 1, 2 is the drawing's half the size of the actual part. So, or in other words, 2 drawings make 1 part, kind of thing. Let's put it at like 2, 3. bigger. 1, 3, perfect. Yeah, that's weird. Strange. Yeah. So there's our little drawings. You can put them as close together as we want. Since I put them all at once, they kind of like mated together. You can put them individually. You just kind of got to press escape between each one. Now it lets you arrange them like not 90 degrees to each other. This, by the way, is like a 3-angle drawing view, I think it's called, because it goes front, right, up. In Asia, they use like front, left, and then like up. Like this one changes. Instead of it being the right view, it's the left view. It's kind of weird, but that's what they do in Eastern countries. But for an assembly, it's generally good. You have the 3 cardinal views, and then you have your isometric just to kind of show you. It's not specifying anything, it's just showing you how it's supposed to look. So I think that's pretty good. Wish that was a little bigger. You could change that, fit it somewhere if these weren't mated together. But for now, that's good. So as you can see, if we zoom in here on the bottom of the page, this has actual information. This is an actual engineering drawing sheet. And so we can specify things in this: finish, material, title of it, revision, drawing number. Solidworks always slaps whatever the name of the part is into the drawing number. It's not a good practice. It also says the scale down here, the weight, the number of sheets it is. Um, let's edit that. So to edit that, you just right click anywhere on your main screen, the main window, and you hit edit sheet format. And bam, now you're editing the sheet format. First thing I want to do is get this giant demonstration card 2 assembly out of the way. If you hover over it, you'll see the bottom of my cursor is like A with a dot on it. That means there's a text box there. You can click on it and you get this whole little text box screen. And drawing number is usually used to specify what number the drawing is out of a series of drawings. So bam, this is the first drawing in our series of drawings. So we'll slap 1 on it. Bam. The title of the drawing is the name of the part, usually. So sometimes to find these little text boxes, you kind of got like look for the middle of the whole box and then click on it. Double click, actually. So the title of this one will be like car. And then if you press enter, it's going to enter. So you got to press escape. Bam, you can drag it around. See, like right here, it's just saying like, oh, you're looking over the sheet. But then if I keep going to the right, bam, there's the little A with the dot, and that means there's a text box there. Right here is where you put your company name / organization. So in my case, I'll put UTRGV, basically. Bam. It's the escape. Finish. This is a little toy car, so it's going to be made out of wood. So sand, smooth. That's a little small, right? So this thing, SolidWorks isn't a word processor, so you kind of got to select what you want to make bigger and then make it bigger. Or like this one's also small, so just make it bigger beforehand. The material, oak wood, very fine wood, very nice wood. This scale thing doesn't always update. It is programmed, like it deletes the whole scale thing at once, so that means it's programmed to something, but it doesn't update when you change the drawing sometimes. So if you're doing this professionally, you're going to submit these drawings somewhere, always make sure that scale is correct, because these drawings are for someone to make your part or to specify to a manufacturer. You want to make sure all the information is correct as possible when you make these drawings. So scale we put was 1 to 3, I believe. Yeah. Bam, there's even things here, and this is like a real professional thing. Put your initials for whoever drew it, checked it, approved it, thing that's manufactured it, and then quality assurance, yeah, quality control. Then um, yeah, name, signature, date. Like after you print it out, you sign it. Um, the date is 9-12-20. And then this is for tolerances. We don't really have any here. It should be inches. My SolidWorks is in inches. It's weird. Um, but this pretty much just specifies if you're drawing, when you're drawing, you're putting dimensions. If the dimensions don't already have tolerances on them, it's like, uh, oh, this is the default tolerance kind of thing, linear, angular tolerances, surface finish tolerances, things like that. But we don't really need to specify that. We didn't go over any tolerances, so we're not going to wait about that. Revisions is if you have um, a part that's undergone multiple designs, like multiple tunings of the designs, you'll have different revisions. So you'll put in here like revision B, like you submitted it once, that was revision A, and then someone made some change to it, so it's revision B, that kind of thing. We're not dealing with that stuff. So that's pretty much it. We don't have a weight, so we'll just leave it like that. And whoop bam, there's our part. So some of you who may be familiar with drawings, this is a huge review. Uh, oh, by the way, let's rename these sheets. It's always good to have these documents organized. If you go down here, there's a little tab right here at the bottom where you can edit your sheet format and stuff. But one of the main things is rename. And so we can, well, bam, we can rename the part. As you can see, it gets reflected up here. You can also rename it here, I think. Yeah, you can rename it, but it's just called rename tree item for some reason. So uh, one of the main things that's annoying is that if you keep just clicking like new model view or like new page, it just like keeps erasing all this information. It gets real annoying changing it after a while. You can literally just copy this one and then Control V, paste it. It's usually good to select move to end, and then I'll slap it there. It's called assembly 2. It's the exact same thing as the first page because it's a duplicate. We can rename that. Our next part will be the body of the car. We can literally control select all of these drawing views, delete them, yes, hit this yes to all, bam. If we open up our palette here on the right side, it was compressed because I was like interacting with the screen, but right here on the right edge of our uh, little view, our main window, you can select this view palette and see we're still on the demonstration car 2, the main assembly. If we click down, we can see all the parts that we have open right now. If you don't see them, you can click these triple dots and you'll be looking through your files, so you can do that there. So first thing we want to do is the body. In my case, I named my body demonstration card 2. So we'll click on that and see the little drawing views here at the bottom. They changed. So if you can just drag the front view, well, bam, right view, top view, bam, cardinal. You don't normally put, unless your part is exceedingly complex and you want to like show how it looks in a 3-dimensional space, you normally don't put the isometric. So like we're gonna get into normal conventions for engineering drawings. Use custom scale. I don't know why it's defaulting to 1/5. It's making these parts look tiny. We'll put 1/2, see? Looks very nice actually at 1/2. We'll check mark that. It's just real fast. Edit the sheet because like I said, this sheet was a duplicate of the first one, but it has all the other information. We deleted all the other information we didn't need. See the scale's already, oh no, the scale's 1/3, so we'll change that. So edit sheet format, we just right click the screen and hit edit. we'll leave all that there. I'm doing this on the same day, so I'm going to change that. We'll change the scale to 1, 2. Check mark that. You can also press the check mark on the left side instead of escape. The drawing number, this is the second drawing in our series. This is no longer the car assembly, this is the body. And everything else is the same. Exit that. And what bam. Now we're just looking at our drawings. We're gonna, to put actual dimensions and things like that, you gotta switch the tab. Hold on, I'm sorry, I need to go let my cat out. She's meowing. All right, I'm back. So in order to actually put dimensions, you gotta go right here at the top left. There's a tab called Annotation, Smart Dimension, just like when you were sketching. It's like the same thing. And you just start selecting shit and you start getting numbers. What bam, what bam, what bam. It's very easy. There's only one thing, one very crucial thing. The default color for SolidWorks dimensions in drawings is this weird gray color. It doesn't have good contrast, and it's honestly weird. I don't know why it does that. It's not standard. But this is like the default. All SolidWorks do this. There's a way to change it though, and I will show you now. The first thing you gotta do is get this toolbar at the bottom. Is install this toolbar off the internet. No, I'm just kidding. To get this toolbar, which is called the line format toolbar. I'm sorry, right here. Oh, bam. I'm just gonna come over here. SolidWorks has like two of this top rows things. It's normally like save, print, and stuff. If you go to the left a little bit more, it'll pop out these extra ones. They're like file, edit, insert tools. So we're gonna go under tools, and we're gonna go under customize. Yes, customize toolbars. See the first tab should already be selected. It's got all the SolidWorks toolbars. The one we want is line format. I already have it checked. If you don't have it checked, click that check and it should appear down here. And we'll click OK, right, after we check it. And so if we select this dimension and we go over here, you have different layers. You can change layers, layer properties, line color. The thing we want to do is change layers. So pop up this extra little text box. It's kind of faded out, but if we hover over, it'll be one. See, none is like, it's just putting whatever default color SolidWorks wants. You gotta specify your own. In my case, I have one called format that I specified, and what bam, it's black. Yeah, if you click layer properties, you can specify new colors. New layers is what they are. And what these let you do is you can have like one layer that's just diameters, and you can specify all the diameter things a different color, that kind of thing. In our case, we just want all our colors to be black because that makes it very good contrast, easy to see. It's very easy to understand. In our engineering drawings, you can even specify the style of the line. You can make it dash, solid, thick, thin, that kind of thing. The thickness of the line, those kinds of things. You want to make a new one, you can click here, be like layer one, see, and then you can change the color, that kind of stuff. You can go to town with it, but for now, I just want my format because my format is good. And now that we're in the document layer format, all of the other dimensions we make should, see, be black. So yeah, that's the general thing. And so now we get into doing things the engineering way with these drawings. So, you know, you just specify things you think should be specified and try not to overcrowd it. It's one of the main points. Someone is going to be trying to read these drawings. The last thing you want them to do It's just be like, there's too much shit on this paper. I'm not going to do this correctly. So things like that, specifying the chamfer, specifying like where things are. This isn't the best part to be specifying things on, to be honest. Um, but for all intents and purposes, this is how you make these drawings. Uh, you got to know where these holes are placed. So as you can see, SolidWorks recognizes that these are holes. They go through the part. So it gave us a nice little center mark for these holes. And we can specify from there what these dimensions are, where these holes belong. If we click center mark to center mark, that's weird, did that. If we click, sorry, hole to hole, bam, right there, it gave us the distance between their centers, that kind of thing. You can drag these around. If they're not centered, when you have a dimension selected, it gives you this whole menu. In it, you can specify the precision of the uh, dimension. So like 3 digits, 2 digits, it defaults to whatever the document is. You can center the dimension. See, there's where it says dimension text at the bottom. There's this little center button on the left, and then to the right of it is offset text. And I'll show you what that does right now. Just center these. You can do nested. Why did it do that? Stop it. SolidWorks sometimes shifts things around. In general, you want to keep your dimensions out of this box because then you're overlapping with text. Sometimes you gotta move things up, get that ample space. It's good to nest, you can nest your dimensions like this just as long as it's clear what you're trying to convey. But as I was saying about the what this offset text button does, again, when you have a dimension selected on the dimension text little tab, if you click it, well, bam, this thing is now on the side instead of like being sideways. So that's sometimes good to make these things easier to read. You can also, like, well, bam, do that, things like that. So I'm not going to tell you like every little thing to define on this thing. Would be good to define this, I suppose. You should know what needs to be specified on the part you're designing. It helps to think about it like if you were going to actually make it. In the case, since we're university students, we can't employ other people to make our parts. We are going to make it. So it's very vital that you specify the dimensions you need as straightforward as possible so that you can follow them when you're making your part. Um, I hate to say it, machinists aren't always the brightest people. So if you can do math for them, that'd be awesome. And it's not just machinists, it's also for yourself if you're making the part. So, like I said, this is like redundancy. See, I already have this 3 and 6 there. It's kind of redundant. Just to reiterate what kind of view it is. Gives you a better 3-dimensional, like seeing it in 3D kind of thing. So we'll check mark that. That's good. Body check drawing 2. Well, that's good. All right. Well, we're done with our second drawing. So now do the same thing. We still have our assembly sheet copied, so we can just Control V to paste it. Move to end. Same thing. Actually, the thing that really helps, yes to all, is if you copy something like this, like like you do your page. Um, you make your little page. Watch, let me edit sheet format. Let me just clear that. Clear that. And right here, just set the scale to like nothing, right? So It's got everything we know all of our parts want. It's got like the name of our company. It's got the sand smooth. All our parts are going to be sand smooth. They're all going to be made of oak. It's got my name. It's got the date, right? We're going to exit that drawing view, and then we can copy this. So now we can just paste a blank page without having to delete the other drawing views. This just helps speed up when you're making drawings. Some assemblies have, 50, hundreds of 50 to like 100 parts, and you just gotta trying to make the drawings fast. Whole point of this software, CAM and stuff, is to make drawing things faster. So we'll do the axle next. Oh no. Alright, so here's the fun times. Um, we could actually fit one to one, see, but standing it up, it's pretty janky. We don't really want to do that. So if we want to rotate a drawing view, we can right click the drawing view. We can go to zoom pan rotate. It'll pop out this menu. We can click rotate view. It's got a little clockwise move. And it'll pop out this little dialog box and it'll ask for degrees. In this case, we're going to move it 90 degrees. And we'll check apply and bam. There's our same view rotated 90 degrees. And this is awesome because now we can fit that and the right view together. We can put the right view. And yeah, if it's not letting you select the scale you want, make sure you click custom scale. And then you can bam, specify that. God damn it. No, I want this to be custom scale, 1 to 1. Bam. So that's pretty nice. It's a neat little trick to rotate a part in a drawing view. Not every engineering drawing has to be those like cardinal views, the front, right, top. Some parts, in the case of this axle, are extremely simple, and it just helps to specify the only main things you need. And I'll show you some other tricks in a bit. Another thing you can do is if you have a drawing selected, you go to this left-hand side, you can specify different ways of viewing the part. In this case, we want to put hidden lines visible, which shows like boundaries within the part, aka holes in the part. And this just helps visualize that, okay, this square in this top view or our front view goes all the way through the part. I see. I see what's going on here. So that's a check mark from me. What are we going to do next? Well, I'm going to slap this name on here. It's going to be Axel. Alright, press escape. Drawing number. This is 3. And I'm going to exit edit sheet format. That's in the top right. Let's do some basic dimensions. Yeah, that's pretty good. I personally don't like that it's like that sideways, so I'll put it like that. It's pretty nice. You can click like 2 lines to get the length, or you can just click the line that is the length if it goes all the way to length. If you have a chamfer on that end, it's not going to go all the way to length. But in our case, there's no chamfer, it's flat right at the end, so it will give us the direct measurement. We'll check mark that. We can slap the same thing here just to kind of show, it's the same thing just sideways. And now we want to specify that little square, the dimensions of it, but it's pretty small and it'd get pretty congested just trying to like put lines, a bunch of lines there. So what we can do is if we go back to the view layout tab at the top left, we can go here, a detailed view. And what we're going to do is we can just zoom in here, click on an arbitrary point, and it's going to start forming a circle. We can drag it out, and well, bam. So this is a zoomed in or detailed view of our part. We can just click it where we want it. SolidWorks is smart. It knows what you want. We'll say detailed view. It'll increase the scale of the part. We can also change this. We can specify our own scale, same way. Right here, scale, we could put whatever scale we want. In this case, this 2 times view, and 2 parts equals 1 drawing, so it's doubled the size. This is fine. And we can start dimensioning here, except I want to specify where the center of the square is from here, this edge. So in order to do that, I need to put what's called center lines. So if we're on annotation, if we go all the way to the right, right here is center line. Well, bam, you choose 2 lines and it'll put a line right being in the middle of them. Well, bam. And so that helps specify. With circles, there's this one called center mark, and it'll do it automatically. You just click the circle. And that's very good for saying the center of a circle is this far away from this edge, so they know how far to go on a mill from that edge to drill it, or make it, or whatever contour shape it is. So smart dimension will specify that this is indeed 1/10 of an inch. No, it's not. Oh, right. This is kind of like auto placement. If you have like awkwardly positioned things, sometimes hovering over the circle will like help you. Um, I know one time I was like positioning something really weird. It was like at a certain angle and it was like projected from the drawing view. It was kind of weird. And then I just hovered over that circle and like fixed it completely. I was like, oh, nice. Awesome. It's awesome. Uh, so in addition to that, I want to specify how far from the edge this was. Um, I know. Uh, Not the best drawing views, but straightforward. And see, uh, in the case of this dimension, is this 13th of an or 0.13 of an inch? No, it's actually 0.125. It's just getting truncated because of the document precision. So we got to go to the dimension with the dimension selected, go to tolerance and precision, and specify that we want an extra digit. And well, bam, there it is. And geez, shot it all the way over here. Bam. So that's pretty good. I like that. That is very nice. You can rename these detailed views whatever they want. Usually they go down like the alphabet. And they keep preceding each other. Like if I made another detailed view on another part, it would be B because A is here. So I think that's good. All right, we need to rename the sheet. Come down to the bottom. Rename, or you can rename it here on the side. It'll be Axel. Well, bam. Check mark it. It's Gucci. Uh, See, right here's the add sheet, and it would give you like a default sheet, like the first one we edited. And again, to save time, we're just not going to deal with that by having our own default sheet to like copy paste. Oh, assembly 2.2. Just go ahead and rename this first. Next part is the pin. So right click, edit sheet format. The title of this is pin. And the drawing number is 4. And the scale is, well, we haven't put the part in. I'm going to tell you right now, we're going to do this 2:1, as in 2 parts equals 1 drawing, or the size of the drawing is double the size of the parts. All right. So that's good. Escape, exit sheet format. I'm going to click on our little view palette right here on the right. we're gonna go, wait, is the pin, okay, pin car2 is here. Bam. So you can see this pin is exceedingly tiny. So what are we gonna do about that? And see, like the other one, this is an extremely simple part. I'm just gonna delete that. Let me just, let's do it just top and front. See, so just top and front. It's an exceedingly simple part. So we really only need 2 views to specify everything we need about this part. And like I said, we want this to be 2 to 1. So on the scale, we're going to scroll up, look for that hidden user define. We'll put 2:1. We'll press enter and bam. Now this looks actually sizable. I'm going to smart dimension it. Bam, 1/2 inch by 1/10 of an inch. It's kind of add that little layer of redundancy. So sometimes you just gotta zoom in, and bam, that looks good. That's pretty straightforward. If there was anything to be changed, it would just change this to inches. It should say inches. I don't know why it's saying millimeters. My SolidWorks is in IPS. Yeah, just so that everything's in millimeters. But we can also specify that. So if we're in the annotation tab here at the top left, same place where the smart dimension is and stuff, if we go a little bit to the right, there's note. And this is just like any free drawing you want to write. This is very good for any specific specifications. That's the same word twice, of your part. For instance, threads. You don't normally smart dimension threads. I don't even think smart dimension can do threads. You normally just type like thread and then like, I don't know, half, not 12 dash, like half 18, you know, and you'd have like a line pointing to the hole or something. In our case, we just want to say like note colon scale. Scale is to :1, so that someone, when they make the part, they're like, why is it so tiny compared to this drawing? Just make sure to point out to them that yes, this is a 2 times size drawing, and also that unit inches, you know, all dimensions, that kind of thing. Can make this larger, slap that bold on it. Now anyone can see that. Put it in a place that's easy to read. Sometimes in the middle it's not good, so I misspelled dimensions, probably. Anyways, see, so that's very good. Threads, you need to put this note. Any other specifications that you can't describe with the simple dimensions, you can do. All right. And that's, again, just to help anyone who's going to manufacture. You specify these little things that need to be done to make this part. There are little specifications, heat treatment processes, those kinds of things you just slap on the end, heat drip, heat treat, hot dip it, whatever you want, do to it. And yeah, so that's it for the pin. Again, very simple part, very simple drawing. And we're just gonna copy paste, Control V, move to end. This is our fifth and final drawing. Edit sheet format. Title will be wheel. Drawing number is 5. Scale will be 1:1. Is it still selecting all of the scale? Oh no. Alright, yeah, 1:1. And that looks good, so we'll exit the sheet format. While we're on sheet format, we'll rename the sheet. This will be who. I'm gonna press escape instead of enter. Name, enter. So, we want to again go to our view palette, little tiny icon on the right. We're gonna select our wheel, and then really only need 2 views. We'll do a special view just to really show the inside of the wheel. So we really only need the front, the right view. We'll change these to 1:1. Yeah, that's good. Let's bring them down a little bit because our special view is going to be somewhere at the top. It's smart dimension. By the way, if I didn't mention it, this kind of phi symbol or Norwegian U letter is diameter, by the way, just in case you didn't know that. Center that. Solidworks is doing this arrow thing. Try to line it up 90 degrees, especially if you want it to be 90 degrees. I like the 90 degrees line up. You know, it's pretty good. It's pretty Gucci. Yeah, you can nestle things under each other like that. 30. We kind of splined all these things, so this radius isn't exact, so there's not really a point in defining it. But yeah, so the special thing we want to do, that's the general dimensions of this wheel, is we wanted to put a section view, what's called section view, right in the middle of this thing so that we could show how it looks on the inside. Because like right here, this is supposed to be the side profile of it, or it's our front profile in this case. But you don't really appreciate how it looks when you get towards the center. You get me? This whole surface is curved, but you can't really see that curve. So we're going to cut it in half and show that section. And the way we do that is, we select one of these drawing views. We go to View Layout, and up here at the top left, by the way, and you go all the way to the right, near in the same section where Detailed View was, just a little bit to the left, is Section View. You select that, and see it's kind of going to give you like this thing already, and you can drag it around and see it's like, oh, which thing do you want to section? This drawing? If we section this drawing like this, we're going to get the same kind of view as we have on the right, so there's no point in doing that. You can change like the cutting line to horizontal, auxiliary, like at an angle, or like a line, like all these weird things. This is kind of like for the breakaway views and stuff. So we'll do horizontal. We'll do it on this one. We want it to be right in the origin. It'll kind of snap to it. We'll click it, and then we'll click this check mark, OK, and wha-bam. See, so now we have that cut in half view, and it kind of, oh shit, it already like, it has the hatching already, making it look real professional, and stuff like that. Usually this is mated, so you can't kind of like drag it around. I think maybe there's a way to break that mate, but I'd have to look for that, and it's not. Uh, but for now, you can change the scale of it if you want. You can do all that stuff. See, it's section BB because these lines are B, B. You can reverse the direction of these lines and stuff like that. Usually they point towards your drawing. If they're not, you should make them point towards your drawing. Um, and yeah, you just kind of click them and change the direction. Uh, yes. So as you can see, we get this nice little view. This radius is already defined, but we kind of want to specify how wide this cut is through the middle, like how wide this flat part is. So we'll just go back to annotation, smart dimension, bam, bam, and there it's a 1/6 of an inch. Bam. So yeah, that's good. Sometimes you don't even need to like do these, but they help with visualizing. Um, Especially in assemblies, you can do these also for assemblies. It'll just help to show where parts are in relation to each other, how they fit together, things like that. And that's pretty much it. Um, you could also do uh, exploded views and stuff, but you'd have to configure those, and that's something for another workshop. For now, that's the end of these drawings. You know, you give them one more look-see over, make sure everything's right, and then we save them. So we'll hit that save. Um, you know, it's going to ask you if, oh, do you want like, if it has dependencies, it'll say like, oh, do you want like save these too? Yeah, if it's going to update a drawing preview. See, and like I said, these can have the same names as the parts because they're different files. So it's always important to like look at the type of file you're doing. So they're drawing files, draw, SLD, DRW, that kind of thing. Yeah, that's good. We'll save it. So now this drawing file is saved, and it will like when we close it and open it, it will lead to these. But we can also save it as a PDF or really any image format we want. And that's good for showing it to people or printing it. You just hit this save as. Yeah, sometimes it's update drawing view, bro. It's kind of weird. And see if you click this drop down arrow. Right now the drawing is selected because that's the default. You can save it as like different drawing type files, like different engineering type files, drawings, or you can save it as a PDF, Adobe Portable Document Format, straight up a Photoshop file. It's pretty crazy. Illustrator, JPEG, TIFF, PNG, the best. We want it as a PDF. Well, bam. You can save it. It'll ask like, okay, what do you want to exports? And then you just make sure all the drawing names are selected. Click OK, and it's got like, and then it's done. So you can go to your files. I already have one open here and see what bam. You can click it, and I have mine in my other window. What bam. It's got it. Even like sections it. It's pretty Gucci. It's pretty nice. You can scroll through it. It's different pages, just like that. Ooh. Did I not put the scale for the axle? Damn it. But for all intents and purposes, that's it for this lecture, workshop. Got any questions from the chat? Please. What's up, Jude? You got a question? Yeah. Well, I hope all you new freshmen or new engineering ASME members found this informational. Uh, Hopefully you will be applying these skills soon in our projects and things like that. So I hope to see that happening. Uh, oh no. Okay, I'm back. Jude, can you hear me? Okay. All right, my Zoom like froze. Um, okay, well, there's no other questions. Uh, that's pretty much it. So thank you for attending and watching this workshop. And like I said, hopefully you use these skills soon. The best way to work on your SolidWorks is to practice, find something around your house, measure it, design it, assemble it, that kind of thing. Uh, find things online to try and assemble. And yeah, best way to learn is to practice. So yeah, until next time.